Hey everybody, this is Nick from Kano 3D Services, here to do a real-time CAD reverse engineering demo. So I was on a bike ride this past weekend, and the mount I have for my phone broke. My phone fell off, but don't worry, it is okay. And I figured instead of going out and buying a new phone mount, it would be a really good example to show people how I would take some CAD skills, a little bit of reverse engineering, and 3D printing capabilities, and recreating the part so I don't have to spend more money on a new mount. So, if you like this kind of content and you want to see more in the future, please make sure to like and subscribe. So usually if I were to go about reverse engineering something, I would take this part, I would do a rough sketch of it with a couple different views on paper, and then I would add my dimensions to it, but for the sake of this live demo, I figured I would actually have my camera going and show you guys how I take my calipers and obtain my measurements. So for the sake of this demo, I'll just do everything live. So we can basically get right into it. So when I look at a broken part, or really any part I'm creating, I try to look at all the different pieces and break it down into the most basic geometric shapes I can. So for this one, I'm seeing kind of three separate things. I am seeing a square with holes in it, and obviously these pieces are broken off, but it is square. So I see that. I see a sphere with a flat portion cut off and a hole through the center. And then on the bottom, I see these little indexing pins, and basically these are here to just keep it in place from rotating or popping out. So I'm basically seeing those as three separate things, and usually I like to take the most basic shape, which for this example would be the square, and I would start with that. So I'm going to go ahead and turn my calipers on, and what I like to always do is just a little tip is usually every few measurements I like to bring my caliper jaws back to 0, make sure they actually sit at 0. You don't want to go too far into measuring a part and have your calipers drift out a little bit, which does happen, which is why this 0 button is right here. So again, a good tip is always try to go back to 0 every so often. So I'm going to take my part, and I'm just going to start with some basic dimensions. So the very first one is getting the square shape of this, and I am at 1.264, 1.265, which sounds nice and even, so I'm going to go to Solidworks, and on my top plane, I will insert a center rectangle. I'll control the top and left sides and set these equal since it's square, and then I will type in 1.265. Go to my Features tab and go to Extrude, and I'm going to go downward. So now what we need to do is we need to take a measurement of the thickness of this square. So again, back to 0, take a nice measurement of the thickness, and for this I'm at 0.115. I do love even numbers. So I'll extrude this down at 0.115, select OK. And one other tip you definitely want to get into the habit of is Control S or the save function up here. You want to try to save as often as possible. SolidWorks is a computer program. It does have the ability to crash, so we always want to make sure that we save as often as possible, so in case we do happen to get a crash, we aren't losing work. So I'm going to go to my top plane, and now I'm going to take care of the hole pattern. So since this is square, I'm going to insert a center rectangle, right-click on the edges, and say For Construction. And then I'm going to insert 4 holes on these edges, hold Control, select all 4 of them, and say Equal. So now I'll put a diameter dimension on this, go back to my part and calipers. On the underside of the part, I will use the top jaws of the caliper, which are good for doing, I guess, gaps or diameters. Again, we're at 0. Just start opening my calipers up until they get, again, we don't want to squeeze crazy tight, but we do want to make sure that there is a good force on this. So as you can see, my part is, staying in place on those jaws. I am at 0.124, 0.125, which is 1/8 of an inch, 4 holes, so 0.125. And then I want to take this line and this line, set them equal since this is a square pattern, and now we get to the fun part, which is measuring the center lines of a hole. So there's 2 types of dimensions. There are size dimensions, which are controlled for the diameter, and then there are location dimensions. So to measure a hole, in theory, we could take this part of the jaw and go inner edge to inner edge, but if you're doing anything for production, usually the standard would be to do center to center, because people don't like to get this because of just general tolerancing. So what we'll do here, and again, we're going to take a little bit of a guesstimate here. I'm going to take my jaw and get it to be roughly in the center where I think it is in the center of the hole, and then I'm going to just use my thumb to kind of keep it indexed in a decent spot. Try to keep this steady for everybody, so I'd say about right there. and then we're going to open the other side of the jaw until it looks like it's, again, roughly centered. Most hole spacings for especially parts like this are going to be something nice and exact, so this actually looks almost perfectly on center, so we're going to call this 1 inch for the spacing of the holes. So I'll insert a dimension, and I will say 1, and as you can see, we are fully defined, which is what we want. I'll go to Features, Extrude Cut. We're going to do a through all both. Technically we could just do through all, but I like to do both just in case. So again, quick control, back to my front view. Or sorry, top view. So the next part we're going to look at are these corner fillets. You can see they're rounded. And usually I would just use a fillet command, but this one can get a little challenging trying to measure a fillet. So what I like to do, especially for something I'm reverse engineering, is when someone was designing this part, they would make sure that this corner fillet is going to be concentric to the hole, because if not, you would have non-consistent wall thickness, and this band that goes around wouldn't really work well, and you kind of just don't really, it's just bad design practice. So I'm going to insert a circle, I'm going to make this tangent to my walls, and then I'm going to go ahead and insert 2 lines to the center of this, and then I'm going to trim off the rest. And the reason I like to do this is, let's say for example my measurement was a little bit off when I go to prototype this. If I were to move my holes or resize them, this would keep shape, and that's exactly what we want, versus if I had a measurement controlling this and a measurement controlling this, if this one changed, it would not drive this one to change. So I like to do it this way. I'm going to cut one of these corners, again, do a through all both. So now I have one of my corners done. And we like to save time and use patterns wherever we can. So I will take my right and front plane, highlight them with control, select them, and then do reference geometry axis. So now that I have an axis in here, I'm going to take this cut, go to my patterns, circular pattern, and select my axis. And usually by default, it'll be 360 degrees with 4 instances. Click OK. And now again, this and this are concentric, and it gives us a very nice consistent shape. So now that we have the rectangle mostly defined, we will move on to the fun part. And that is going to be the kind of sphere, or the socket shape, whatever you want to call it, that has the flap. So this is obviously revolved 360 degrees around this. So what we'll do is we'll just do a little bit of setting up on our front plane. And again, we're going to draw basically a section view of this, and then we will go ahead and revolve it outwards. So first things first, I'm going to draw the rough shape, make sure these are tangent. Then I like to do a center line. I know we have an axis, but I like to use the center line as a definition point. So what I'll do is I will draw a center line, set it to construction, and because this is around the center, we're going to want to make the center line and the midpoint of this arc touching or coincident. So I'm going to do this, drag that out a little bit, and then what I'll do is I'm going to go into offset entities and offset this out, but I'm going to unselect add dimensions. This allows me to drive it a different way while still maintaining the exact same shape, which is good. So these are now linked together with no dimensions, and we can kind of go in and fill these in. If you look at the shape at the top of this hole, there is a chamfer. It's like a little bit of a relief. So we're going to draw that in here, and we can use that. We'll define that again later. So I'm going to drag this up. I'm going to insert one more line at the top of here, which will represent the total height of this little socket shape. So I will do that, and this setup looks pretty good. Things are moving, and we could basically just go in and start adding dimensions. So the first dimension I want to take care of is the inner diameter. So if you see, I drag my dimension to the right, I get half of the diameter, which would be the radius. If I drag it to the left, I get the full diameter, and that's what we're measuring. So typically I like to control it this way. So I'm going to put that there. I'm going to go to the underside of my part. I'm going to go as close to the bottom as I can. If I go inward, I'm going to start hitting the curve of the wall, so that's not going to be accurate. So I want to try to get as close to the bottom as I can. Open that up, give it a decent pressure, and we are at 0.905. So this will be 0.905. It'll push this out. So usually if I was modeling something from scratch, I would like to control the wall thickness of something. That's going to be a little challenging in this part. The only real way to get decent measurement for that would be to almost cut this in half, but it is curved, so that makes it challenging. So what I'm going to do is I'm going to control the inner diameter, like I just did, and then I'm going to put a dimension here from the outside of the square to the wall, and that will be controlling the inside and outside, so the wall thickness will be driven based on those dimensions. So if you wanted to, you can use the top portions of your caliper to kind of guesstimate this part, so you're locking it against one side and then kind of using the other side to guesstimate, but usually what I like to do for that is I will use the bottom edge of the caliper, so the depth portion. I will put this on the edge of the square. I will extend the jaw a little bit and then try to make it as flat as possible to get a good measurement. So when I do that, sorry, let me do that again, a little bit slower. So square up here, bring it down, and then sorry, one more time. Got a little bit of flow here with my hand. So pull this out, flatten it. And for this, I'm at 0.079. And I'm going to chalk that up to 0.08, just for a little bit of float I had there. So we have the location of this now, and now we want to take care of the height, so I'm going to select my center line. I'm going to do a similar kind of process. I'm going to take the bottom portion, try to get it as flat on here as possible, drop this next portion down, and that looks good. So 0.495 height. Pretty happy with that. So the last two dimensions we need to make this fully defined, usually for a chamfer you would do something like this and control the angle, but measuring that angle on a part that's made is a little bit challenging, so instead we're going to do the inner diameter here. So what I'm going to do is take, again, the jaws of my caliper, and I'm going to squeeze it on the inside, and I am at 0.605. So 0.605, and that's going to then drive this, and we are now fully defined, and I just need to add one more line here to make this a closed shape. Oops. And now that we have all this defined, we can go ahead and go to Features, Revolve, and then select the center line, revolve around, and we have our shape. So we did something right, we'll save it. So now, one last quick thing on here, I'm going to go to my top plane. I'm going to go ahead and select this edge right here and convert entities. Features, extrude cut. We don't want to do through all both here, we want to do just through all going downward, and that will now cut out our bottom shape. So again, quick control save. So the last kind of geometry part we're going to draw are these little indexers on the bottom, and these really just look like kind of like quarter circles, almost like the shape of like a Cheeto or something like that. And you can tell that they're concentric to these center holes. So to start this shape, what I'm going to do is I'm going to do a sketch on this face, where usually I would do it always on planes. But for this instance, the top plane is on this top surface, so I think it's safe to draw this on the face. So I'm going to do one circle, a second circle, and the very first measurement I will take is the thickness between these two. So I'm just going to take my calipers, give it a pretty good squeeze. I'm at 0.075 for the thickness of this, so 0.075. And then if we look at this again, we can see that there is a horizontal line here and a vertical line here, if I could get this to focus. So just to get this shaped a little bit easier, I'll just insert two kind of arbitrary lines, and then I'm going to take my trim tool, trim out everything around it, and I'll be left with something like this. So we have two more things to control: how close it is to this top edge, and then how far away it is from the circle. So first things first, we'll do edge to edge. And again, same thing, if I were to take the outside jaws, start here, and then kind of guesstimate going out, that would probably be okay. But if I use, again, the depth portion on the bottom of these calipers, I can actually lock it into two separate points. So I get one point locking in here, and then I get the second point locked in when it touches this little bottom portion. So for this, I am at 0.105. I just moved a little bit with my hand. So 0.105 sounds reasonable. 0.15. And then same thing here, 0.105. So now I need to size out the spacing of this, and this could be a little bit tricky, but what I would like to do here is I'm going to draw a line that's going center of this circle to the midpoint of this arc. I'm going to turn it construction. I'm going to insert a dimension, but I don't want to pull up or to the side and get a lateral dimension. I actually want to keep this as an angular dimension. So, and again, we're going to try to eyeball this as best as possible. I'm going to set my right edge to the circle, or to the arc we're making, and then I'm going to keep going out until it looks like I'm just about in the center of my circle, which I would say is about right here. So 0.15, 0.151. I'm going to round that down just a touch to 0.15. So I'm going to go to Features, Extrude, and now what I need to do is measure the height of this portion. So I can take my calipers, do the same thing. We're going to take a depth measurement. So I'm going to lay it as flat as possible and drop it down. For that dimension, I am at 0.06. So 0.06. And one way to just kind of check your measurements, I'm going to save this really quick, is I measured this portion as 0.115. So if I measure this 0.115 and this as 0.06. So one good way to double check that everything is hopefully right is instead of measuring this portion, I'm sorry, getting a little off there. So measuring this portion as 0.115 and this portion as 0.06, I'm now going to take a measurement of the entire overall thickness and just measure it and see if I'm close. So 0.175, it looks like, yeah, 0.175 for the overall thickness. So if I click this surface and do a measure, I'm at 0.175. So that's just a quick way to kind of use a reference dimension to double check your measurements. So I'm going to go to my bottom view here, and we're going to add some fillets on here and start doing just some last minute kind of cleanup stuff. And usually for fillets for things this small, especially because I'm going to be 3D printing this, you can see these fillets are, you almost can't even see how small they are. So I'm not going to go too crazy with measuring that. I'm just going to do kind of some generic numbers, again, just to make things not sharp. So 0.015 sounds reasonable. I'm going to select this top edge and this bottom edge. And now, instead of drawing this again 4 times, we're going to do the same method we did with the holes, or sorry, with the fillets, sorry. We're going to select the extrusion and the 2 fillets. We will go to circular pattern, go into our tree, select our axis, and revolve this around, or sorry, pattern this around 4 times. So now you can see the general shape of this is all done. We just really need to do some last minute cleanup stuff, and those are going to be 2 different things. So first we're going to add some chamfers, since the screws that came with this are countersunk. Again, these are very small, so they would be a little bit challenging to measure, so I'm just going to chalk these up to be 0.02. Again, it's really just to allow a little bit of relief for the screw, but because these are so small, it's not something that needs to be crazy exact. So then I'm going to go in and just start filleting a couple things. Again, just really removing any sharp edges. You can select the face of this to get both, but I like to do edges. Just my preference. So 0.015. We will fillet the base of this part. I'm going to make this one a little bit bigger, so 0.025. Fillet again. I will do, actually I'll take care of these first. So filleting this little relief chamfer. Just again, remove some of those sharps. I will do the top and bottom edge. Flip it over to the bottom side, do a quick save. I will take care of these holes. You can technically add a bunch of these fillets all in the same feature if that's your preference. I like to kind of break things down based on feature. I think, yeah, you do end up having more features in your tree, but it is a little bit easier to control it instead of, so like for example, if you had one fillet that controlled everything and one of those features moved or changed, it would keep giving you errors versus having a little bit of a separate part broken out based on, you know, the geometry. So that's my preference. I like to build, I'd rather have a couple more features that control things a little bit on a smaller scale than trying to do one feature that controls a bunch. So I'll rotate around, do a quick Control S, and then I'm going to go into shaded mode. And as you can see, this part is looking pretty good. What we'll do next is we will print this out and get a prototype of it and do some test fit and see if we are right on the money. So again, if you like this kind of content and you want to see more stuff in the future of how to reverse engineer some parts, please make sure to like and subscribe, and you can check us out at Kano3dservices.com. Thank you so much for watching.